Welcome to a comprehensive course on AI agents. Here we will discuss what AI agents are, provide some examples of AI agents, explore the technologies behind AI agents, examine future trends, and engage in some hands-on development with popular AI agent frameworks including AutoGen, IBM B, LangGraph, CrewAI, and AutoGPT. Introduction to AI agents. What is an AI agent? AI agent is a software entity that acts autonomously to perform tasks or solve problems on behalf of a user or another system. These agents are designed to perceive their environment through sensors or data inputs, make decisions or take actions based on that information, and adapt over time through learning mechanisms. AI agents can function independently or collaborate with humans or other AI systems. Key characteristics of AI agents. 1. Autonomy. They operate without direct human intervention and control their actions based on input data and predefined objectives. 2. Perception. They can perceive the environment through sensors or other data sources, e.g., data APIs, images, text. 3. Decision-making. They use algorithms to make decisions or take actions aimed at achieving specific goals. 4. Learning. Many AI agents incorporate machine learning techniques, allowing them to improve performance over time by learning from experience. 5. Interaction. AI agents can interact with humans, other agents, or software systems to achieve their objectives. Types of AI agents. 1. Reactive agents. These are simple agents that respond directly to stimuli from their environment. They do not have memory or the ability to predict future states. They act based on a set of predefined rules. Example: a vacuum cleaning robot like iRobot Roomba, which uses sensors to detect obstacles in dirt and makes decisions on the fly. 2. Goal-based agents. These agents not only act based on their current environment, but also have a goal that they aim to achieve. They may use search and planning algorithms to decide on the best course of action. Example: pathfinding algorithms used in video games or robots that plan optimal paths to reach a destination. 3. Learning agents. These agents improve their performance over time by learning from their experiences. They can adjust their behavior based on feedback from the environment. Example: AlphaGo, which learns from playing Go games to improve its strategy, or self-driving cars that learn to navigate traffic better. 4. Collaborative agents. These agents work with other agents, or humans, in a cooperative environment. They often rely on communication and coordination to solve complex problems. Example: autonomous drones working together to map a large area, or multi-agent systems in logistics optimization. 5. Utility-based agents. These agents make decisions by considering various possible actions and choosing the one that maximizes their utility, i.e., overall satisfaction of their goals or objectives. Example is in financial trading that make decisions to maximize profits while minimizing risks. 6. Hybrid agents. These combine multiple approaches to act both reactively and proactively, adapting their behavior as needed based on both past experiences and future goals. Example: modern AI systems like personal assistants, e.g., Google Assistant, Siri, that respond to immediate requests while also learning from previous interactions to offer better recommendations. Examples of AI agents in use today. 1. Chatbots and conversational agents. Examples: responds to user queries based on natural language understanding. Google Assistant, Amazon Alexa, Apple Siri. Personal assistants that handle tasks like setting reminders, controlling smart devices, and answering general knowledge questions. 2. Autonomous vehicles. Examples: Tesla Autopilot uses AI agents to process sensor inputs, predict traffic conditions, and navigate autonomously. Waymo, self-driving technology developed by Alphabet that uses a combination of AI, sensors, and planning algorithms. 3. AI in video games. Examples: non-player characters, NPCs, in games use AI agents to respond to player actions, move strategically, or offer challenges. AlphaStar, an AI agent developed by DeepMind that plays StarCraft 2 at a professional level by learning complex strategies. 4. Recommendation systems. Examples: Netflix and YouTube use AI agents to recommend shows and videos by analyzing user preferences and behaviors. Spotify suggests music based on past listening habits using AI agents that analyze audio features and user data. 5. Financial trading. Examples: High-frequency trading algorithms, AI agents that buy and sell stocks in milliseconds based on real-time market data. Robo-advisors, AI agents that provide automated investment advice by analyzing financial data and customer goals. 6. Healthcare. Examples: IBM Watson Health, AI agents that analyze medical records, research papers, and patient data to assist in diagnosis and treatment. AI-driven diagnostic tools, agents that scan medical images like X-rays or MRIs to detect diseases like cancer. 7. Robotics. Examples: Boston Dynamics robots. These robots use AI agents to navigate, perform tasks like walking and jumping, and make decisions autonomously. Robotic process automation, RPA, in industries. Software agents that automate repetitive tasks like data entry or customer service operations. Technologies behind AI agents. 1. Machine learning, ML. AI agents often use ML algorithms to learn from data, adapt to new situations, and make predictions or decisions. Techniques like reinforcement learning are critical for agents that need to learn from trial and error, e.g., robots game-playing agents. 2. Natural language processing, NLP. Used in conversational agents and chatbots, NLP helps AI agents understand, generate, and process human language. Examples: GPT models, BERT, and transformer-based architectures. 3. Reinforcement learning, a type of ML where an agent learns by interacting with its environment, receiving feedback in the form of rewards or penalties, and adjusting its actions to maximize rewards. Examples: AlphaGo DQN, Deep Q networks, and self-driving vehicles. 4. Neural networks. Deep learning techniques, particularly neural networks, enable agents to recognize patterns in data, whether in images, text, or sensor inputs. Convolutional neural networks, CNNs, are common in image processing, while recurrent neural networks, RNNs, and transformers are used for sequential data like text or time series data. Examples: visual recognition agents, NLP agents. 5. Robotics and control systems. These technologies allow AI agents to physically interact with the world, like grasping objects or navigating through complex environments. Examples: humanoid robots, autonomous drones. 6. Multi-agent systems. In environments where multiple agents must work together or compete, MAS focuses on communication, coordination, and decision-making between agents. Example swarms, AI in cooperative video games. 7. Cloud computing and edge AI. Many AI agents rely on cloud-based infrastructure for processing and storage. Edge AI pushes some of the computation closer to the devices themselves, reducing latency for real-time applications. Examples: AI-powered IoT devices, autonomous drones with onboard AI processing. Future trends in AI agents. General AI. While current AI agents are specialized, research is advancing towards general-purpose AI that can solve a broader range of tasks with human-like adaptability. AI-augmented creativity. Agents capable of generating creative works like art, music, or literature, assisting humans in creative tasks. Ethical AI. As AI agents become more autonomous, ensuring they adhere to ethical guidelines, e.g. fairness, privacy, and safety, will become crucial. AI agents are a vital part of the ongoing revolution in AI, with applications ranging from personal assistants to self-driving cars. Their autonomy, ability to learn, and decision-making capabilities have transformed various industries and will continue to evolve, shaping the future of technology.